All right, let's do a couple more pages. So algebraically solve for the exact values of all angles in the interval 0 to 2 pi. Notice it does not include the 2 pi, but it does include 0. That satisfy the following equation. Well, obviously when we solve an equation, we want to set it equal to 0 first, especially if it's quadratic, which it is in this case. So I'm going to go ahead, I'm going to add 1 and add 3 sine x. And I obviously have to do this to both sides because we want to keep that equation balanced. So here we've got a cancel, and we're left with equals 0. And then we want to write the squared term first, which is 2 sine squared x. Then we want to just write the x term, which is the 3 sine x. And then we can write our constant term last, plus 1. And then I like to say, okay, what does that really look like? That's actually a 2x squared plus 3x plus 1. And you can say, if you want, that x is equal to sine x, because we're going to have to substitute in at the end. And I have to do the method of factoring that involves us breaking up the middle term. And the reason why is because our first term is not 1. So I multiply the first and the last term. 2 times 1 is 2. So we're trying to multiply to 2. And we're trying to add to 3. Well, what two numbers multiply to 2 and add to 3? Well, that's 2 and 1, of course, right? So now I'm going to break up this middle term into 2. And you should really pick the one that makes most sense to start with. Does it make more sense to have 2x squared plus 2x or plus 1x? Well, definitely plus 2x, but then we're going to have the plus 1x because I'm using 2 and 1, and then plus 1. Now underline and underline, and here we've got 2x, and then this is going to be x plus 1. And as soon as I write x plus 1, I better write it over here, and that's going to be a plus 1 here. So that's going to factor to 2x plus 1, because I just took this 2x here and that plus 1 and pulled it out. And then, of course, I have an x plus 1 as well. All right, so then let's substitute back in for x, the sine x. So we have 2 sine x plus 1, and then sine x plus 1. All right, now we've set both of these equal to 0. Right, so I'm going to set 2 sine x plus 1 equal to 0. So I'd have to subtract 1 from both sides. That gives me 2 sine x equals negative 1, then divide by 2. And that gives me sine x equals negative 1/2. And we'll deal with that in a hot second. Okay, then here we have sine x sine x plus 1 equals 0. Subtract 1 from both sides. The 1's cancel, and I'm left with sine x equals negative 1. So now that I have that, I have to look at my unit circle, and I have to find when sine is negative 1/2. Remember, sine is that second coordinate. And so that second coordinate is going to be sine right here, right? You can see that the negative 1/2 is in the second coordinate. So that would be a 7 pi over 6. But it also happens right here at 11 pi over 6. And of course, we also have to find when x is equal to negative 1, or sine is negative 1. And that's going to happen right here. That's when you've got your 3 pi over 2, where sine is negative. So we've got our 7 pi over 6, our 11 pi over 6, and our 3 pi over 2. All right, so that's our final answer. We've got 7 pi over 6, 11 pi over 6, and 3 pi over 2. There we go. All right, number 7 here. In the summertime, the air conditioning in a home is set to go on when the temperature reaches 78 and go off when it drops to 64. During the hottest parts of the day, the warming and cooling cycle repeats every 30 minutes. Assuming the cooling and heating cycle can be modeled with a sinusoidal function, if the temperature in the house at noon is 71 and rising, write a trig equation to express the temperature as a function on the number of minutes since noon. Well, we have to find the period. So the period, T/period, temperature period is going to be equal to, it says 30 minutes, right? It says that right here. And we have to get our b, and to do that, to get my b, that's going to be equal to 2 pi over 30. That's just something you've got to put to memory, and that's going to be pi over 15. Okay? Our amplitude, of course, is how far this goes up and down from the midline. So that's going to be 78 minus 64 divided by 2, which gives me 7 degrees. And we can check that in a hot second. The midline is going to be the average of the high and the low, which is going to be 78 plus 64 divided by 2, which is 71. So how can I check my amplitude? Well, we know that if the midline is 71, if we're at 71, and the amplitude is 7, well, what's 71 plus 7? That's 78. And what's 71 minus 7? Well, that's going to be our 64 degrees. So you can see that our midline is 71. It goes up 7 to the max of 78, which is right here, and it goes down 7 to our min of 64, which is right here. And now we're ready really to answer our question. The temperature is going to be equal to the amplitude, which is 7. And since it starts up, since it starts when it goes up, and you don't have to worry too much about that, but it should be a positive sign. And then we've got to do our period, which is pi over 15. Well, our period's not pi over 15, our b is. And then we've got our t, and then we're going to do our vertical shift, which is going to be our midline of 71. So here you've got your amplitude, here you've got your b, which comes from your period, and here's your midline. That's going to be your vertical shift. All right, determine the next time that the air conditioning will shut off. Well, first of all, we have to remember two things. Your period is 30 minutes. Okay. And you should also realize that your sine function looks like this. Woo! And where does the air conditioning shut off? It shuts off right here at the very bottom because that's the coolest part. That would be at our, 64 degrees. And this would be our 71. So it shuts off right there, which is 3/4 of the way through your period, because you can think of this as, let me get a different color here. You've got this, sorry. So you've got 1, 2, 3, 4 parts of sine, and we're really talking about having only 3 of the fourths of it. So we're going to take 3/4 of our period. So 3/4 of our period, 30 minutes. We can rewrite that if you want as 3 over 4 times 30 over 1, which is equal to 90 over 4, which is equal to 22.5 minutes. So when will the air conditioning shut off? Well, remember, this is after noon. This is saying since noon. So it's going to shut off 30 seconds. That's that 0.5, half a minute. 30 seconds after 12:22 p.m. Okay. All right, next one. What's the period of the function? Okay, well, the period is going to be 2 pi divided by this b value right here, which is pi over 2. And I can rewrite that as 2 pi times 2 over pi. I'm just multiplying by its reciprocal. The pi's cancel, and I'm left with 2 times 2 is 4. What's the vertical shift of the function? Well, that's just the up 1. And what's the horizontal shift? Well, it's going to be the opposite of that, right? We think -3, we think left, but nope, it's the opposite. It's going to be right 3. And we've done quite a bit of that. All right, next question says to sketch the graph of the function in the space below. Label your x-axis and at least 3 points to show you have your period marked correctly. Label your y-axis at the midline of the curve and at 2 other places. So what I like to do first is realize that we are dealing with an amplitude of 2, right? That comes from this right here. So what I'm dealing with is something that goes from -2 all the way to 2. But then I have to realize that I've got an up 1. So really I need to add 1 to all this. So add 1, And really what I'm dealing with is going all the way up to 3. Right, I just added 1 to this 2 right here, and I got 3. Then add 1 to my low here, and I get -1. So really, we're talking about going from -1 to 3. And here my midline was 0. It's hard to draw that because it's on the x-axis. But here my midline is going to be 1 with my min at -1 and my max at 3. So just drawing that real quickly, I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to go up 1, 2, 3, down to 1, give myself this. And I guess I could dot these lines or erase them at the end, but we should really just know they're not actually part of the graph. All right, so now we need to graph our first point, and since this is sine, we're actually transforming the point 0, 0, which is where sine starts. And we're going to go up 1 and right 3 with it. Well, right 3 would be the point 3, and then up 1 would be up 1. Or you could just put your marker at 0, 0 and go right 3 up 1 and realize that you're starting right here. Now, we know that our period is 4, so we know that we're going to go out 4. So that's 1, 2, 3, 4 right here. And since it's a negative sign, a negative right here, we know it starts down first. The general shape is down and then up. But we do know at the halfway point we are at the middle. So it's going to go down to our min, going to hit here, up to our max. Oops, it went a little too high, then here. And it does want us to do that a couple times. So I'm going to go out 1, 2, 3, 4 again. Okay, I know it's going to be in the middle here. It's going to go down here, hit that, then up here and hit that. All right, put my arrows on because this does continue. I should label this as -1 and 3 and 1. Fantastic. All right, next question here. Change 5, -6 from rectangular to polar coordinates. Well, we know that r is equal to the square root of x squared plus y squared. And that's going to be r equal to, parentheses, 5 squared plus -6 squared. That's going to give me r equals 25 plus 36, and I get a radius of 61. All right, the next thing that I'm going to do is I'm just going to quickly draw this, and I know that 5, -6 is going to be here. So I know that my theta should be around like 300 degrees or something, or between 270 and 360. So I'm going to go theta equals tan inverse of y over x. In this case, I'm going to just do the positive. It's going to be 6 over 5. You could do the negative, but just realize where it is. And I get theta equals 50.19. If you kept the negative, you would have gotten a negative 50 degrees. So that 50 degrees is right here, which means that I'm actually going to have 360 minus 50.19. And that's going to give me 309.81 degrees. So my final answer has to be in the form of r comma theta, right? We want r comma theta. So in this case, our r is going to be square root of 61, and my angle is 309.81 degrees. Fantastic. All right, thanks for watching, and come back for part 3, please.